So I'm not going to write on the actual test. I assume you have a copy of it in front of you, so I don't need to do that. So for question 1, it says if you flip a coin, what's the probability that it's going to land on tails? That is 1. Yeah, we're going over every question now, okay? So in question 1, you guys should all have 1/2. And I'm going to write the answers exactly as I would expect you to write them down. So for problem 1, you should have 1/2. Do you guys have any questions about that? Nope. Nope. Good. Like, nope. You just write the answer. Good enough. Okay. Question 2 says, if you flip a coin, and we talked about this a few days ago, what we're trying to do is use a probability to predict the number of outcomes. So if you know a coin theoretically should land on heads half the time or tails half the time, then half of 42 is all you have to do on a problem like this. So if I flip a coin 42 times, exactly half of them, i.e. 21, is what the answer is. So this is not a probability question as much as it is a using probability to make a prediction question. But you don't express this as a fraction. It is not a fractional answer. It is 21 times. Yeah. I'm not showing work. Do you guys want me to show work as I go? I'll tell you what, I'll post my answer on Canvas and you can see the work that I do. But like what I wrote, I will do that. What I wrote on my paper was I wrote 1/2 of 42 equals 21, and then I put a circle around that. The answer to this question is 21. I'm just Mike or Aiden had said, should I show a little work? He's right, I should show. Okay, good. Question 3 says, if you roll a 6-sided die, what's the probability that it'll show a factor of 24? When I showed my work on this one, me showing my work was making a list of all of the factors of 24. Now, mind you, there's a lot of factors of 24 that I'm not going to list. I'm only going to list these ones. Why? Because they're the only ones that show up on a die, right? 8's a factor of 24, but you're never going to find it on a die. Same with 12 and same with 24. So I'm only going to list the ones that actually show up when I roll a die. And that is, of course, if you count it out, 5 out of 6, right? Remember, 6 things can happen when you roll a die. 5 of them are desirable outcomes. So the answer is 5 out of 6 or 5/6. And this next question, here's me showing my work again. Again, we're using, no, this one does not relate to question 3. Wow, did you guys even catch that? Doesn't question 3 say factor of 24 and then question 4 says factor of 9? Yeah, so I led you down a bad pathway. I wrote this test. You think I could pay attention to my own work? We all need to redo question 4. I don't know why I assumed that I would have kind of piggybacked off of question 3, but apparently I must have been distracted by some video games or something that day. Question 4 is actually very unrelated to question 3. So that's my bad. So question 4 asks us, so we're starting this over. So whatever you have on your paper is going to be incorrect because I screwed it up with you. So that's my bad. I own it. What are the factors of 9 that you can find on a die? Yeah, I mean, the factors of 9 are 1, 3, and 9, right? They're the only numbers that can be multiplicatively put into 9, right? 1, 3, 9. But the only ones that appear on a die are 1 and 3, correct? You can't find 9 on a die. So again, my bad. We're starting over. I screwed this all up. I'll own it. You know, I'm the first guy to own it when I do. So if we wrote that as a fraction on a die, that's 2 out of 6, which of course reduces to 1/3, right? But that's not the answer to the question. The question said, if I rolled this die 99 times, how many times would I get one of those factors of 9? And so we have to take 1/3, which is the probability of 99. And so this one obviously works out a lot better. What's 1/3 of 99? So the answer to question 4 should have been 33. Apologies. That was a little inconsistent on my part to have 1 and 2 piggyback, well, ish, and then have 3 and 4 not. So my bad. I know. Sorry. Gotta get my head in the game. Are we okay on questions 1 through 4? Okay. So let's get to 5. So now we have this jar of marbles when we get to problems 5 through 10. And the idea is we have 3 blues 3 blues, 4 reds, and 7 yellows. And so the first thing I would always do is count them up. And so when you count up all the marbles, that looks like 14 to me. So somewhere up near the top of that, I just would write this down because I'm going to need this information for every single problem incoming now. So here we go. If you randomly select a marble, what's the probability that it will be yellow? I mean, yeah, exactly half the time. Like the only way to miss this is just you have no idea what's going on. The bottom of your fraction is 14 because that's how many there are. 7 of them are desirable, and that reduces to exactly 1/2. So question 6 says, if you randomly select a marble, what's the probability that it'll be yellow or blue? Remember, the key here is that the bottom is still 14, but the top is the sum of the yellows and the blues. And that's going to be yellow plus blue is 10, and 10 out of 14. You guys should all have 5 7ths on this one. Okay, if you don't reduce, you'll just get dinged, which I hate that. I don't like taking points like that off. It's lame. Question 7. Remember, by the way, on OR, you know how we sometimes have to subtract, but there's no marbles that are yellow and blue. Like, so that's why we don't have to subtract there. Question 7. If you randomly select 2 marbles with replacement, remember that means we put the first one back in. What's the probability that they're both red? So the probabilities are going to be the same. The first one starts out as 4 out of 14, right? Because there's 4 reds out of 14 total. And I'm going to go ahead and reduce that down to 2 7ths. But the thing is, because we're replacing the first marble, the state of the jar of marbles is the same after the first draw as it was before we even started. So I can go ahead and just do 2 7ths times another 2 7ths. You get what I'm saying, right? Like the marbles don't change if you put the first one back. So this one just winds up being 4 out of 49. Any questions there? These next 3 are always going to be harder problems because we're not putting the first marble back. Or if you're drawing 3 marbles, you're taking the first one, not putting it back, taking the second one, not putting it back. And what happens when you don't put it back is you change the whole lay of the land. Like the whole jar is different. The total is different. The everything's different. So these ones you really got to be a little slower. So for problem 8, 2 marbles, the probability that they'll both be yellow. So the first one is 7 out of 14. There are 14 marbles in the jar. 7 of them are yellow. The second marble, I want to be yellow. How many are left in the jar? Yeah, there are 13 marbles left in the jar. Remember, because if I took one out, it's sitting over on the desk, right? So the total dropped to 13, and the yellows I know dropped to 6 because I assumed that I got a yellow on my first draw. You have to assume with probability questions like this that the things we want to happen, right? That's what keeps us kind of ticking along here. So I reduced the dickens out of this thing. I took the 7 and the 14 and made 1 and 2. And then I took the 2 and the 6 and made 1 and 3. And that's how I arrived at my answer of 3/13. You don't have to take that route, but that's a good way, kind of reduce early. Question 9 has us selecting 3 marbles. And so I know right away on this that I'm going to need 3 fractions. So I'm just going to draw them out right now. I'm just going to go fraction, times sign, fraction, times sign, fraction, like that. All right, for the first marble, I want it to be blue. What's the probability of blue? 3/14 is perfect. Now, state of things has changed. How many marbles overall are left in the jar? 13. How many of them are red? All 4, because we did not pull a red on the first draw. We pulled a blue. And then, of course, yes, Peyton, the total drops to 12 now because we've got 2 marbles pulled out. How many of them are yellow? Yeah, all 7 are still in there. So in this day and age where we use calculators, like, I don't know if it's a real benefit, but again, I'm always going to go through, I guess it's an old school thing, and I'm going to reduce. So like, I'm going to take this 4 and this 12 and divide them both by 4 and make a 1 and a 3. And then I'm going to take this 3 and this 3 and make them both 1s. And then might as well, while I'm here, take this 7 and this 14 and make them a 1 and a 2. If you can ever get a series of fractions like this for the whole top or the whole bottom to just be 1s, then you know you're done. Like there's literally no way to keep going. So the overall answer to this would have to be 1/26. And then the last problem in this section is again a 3 marble job. And so we know for number 10 that we need a fraction, a times sign, a fraction, a times sign, and a fraction. The first marble is always going to be out of 14, right? Because did it just totally, sorry, I gotta reset my